Work bridges fundamental thermofluid sciences with applications in energy systems, diagnostics with sustainable technology. He has led the IIT team in developing a graphene based technology that could change the way the world tackles the oil spills, which wreak havoc in the aquatic biodiversity. The innovative work was recently featured in the Times of India on 7th of April 2025 in an article titled Graphene Tech for a Greener, Cleaner to Mop up the Oil Spills. That's a great job done, Chirodeep. We congratulate you and your team for a very research in this field. Initially, I will start with some of the questions, and you can also share some of the knowledge or the uh, videos or photographs about the research you have done, sir. And then we'll open up the house for any questions from the audience. So, to start with, now, what inspired you to pursue a career in the micro or the nanoscale fluid mechanics and the energy systems, Dr. Bakli?
So thank you for the question. Before I start answering the question, I would like to express my heartfelt gratitude to IIT KGP Alumni Foundation India and its secretary Sri Siddhartha Roy Choudhury for graciously inviting me to be a part of this prestigious lecture series. In fact, on the morning of 7th, it was Sir who sent me the first message. I did not know it has been published. So I did not realize, I did not check it's from IIT KGPAFI. So I told him, please give me some time. And I rushed to get a copy of the newspaper. So at that point of time, I actually overlooked it and thought it's the institute media cell who has informed me, and I agreed to give the lecture. Only to later, about 24 to 48 hours later, realize that it is from Alumni Foundation India, and immediately I went to the YouTube channel and I checked the list of alumni who have given the lecture, and I realized that I have been, in a series of lecture which has been uh, given by a series of distinguished alumni from the institute, and immediately I realized the degree of my oversight. So, these are the set of alumni who have, books and movies on them. So, and then immediately I confirmed with sir that whether, there has been a mistake on their part. So he reassured me, no, they want to hear me. So I must here add that the foundation is so closely connected to the institute, irrespective of their busy schedule. They happen to be, so closely connected and following the news of the institute. That is really commendable. So, I realize the gravity of my inclusion in amongst these accomplished individuals, and so today I'm here to share my modest journey and a few stories regarding it. So coming back to the question, what inspired me to pursue a career in an interface of micro and nano scale thermofluids and energy systems. So my undergraduate degree was in energy engineering. So at that point of time, energy engineering was administered by electrical engineering. Uh, and now I was the last BTech batch. So this started around somewhere mid 80s. I was the last person. I mean, our batch was the last batch to graduate. So, from the very beginning, I was deeply fascinated by the interdisciplinary nature of the program and realized that, it is going to be a future. So, however, after we graduated, this got dismantled and reorganized into now what we know as the School of Energy Science and Engineering, where I am a faculty currently. So throughout our coursework, we had subjects of electrical, mechanical, chemical, and allied engineering disciplines. So it became very clear that the challenges that define energy and conversion, energy harvesting, and future energy systems, the understanding doesn't stem from a single subject, but rather a multitude of interdisciplinary and multidisciplinary subjects. And I also realized that fluids play an important role in transmission and conversion of energy systems. So a deep understanding of thermofluids is essential to advance energy technology. So taking a cue from the electronics industries where miniaturization has created a revolution. So a similar revolution is probably impending for the energy systems and energy industry, where a combination of fluid miniaturization and energy can lead to revolutionary and sustainable solution. So that is what inspired me to, pursue a career in this. Thank you.
That's nice, Chirodeep, to hear from you what pursue you. So, who has been your key mentors in or figures who has helped to shape your approach in this field of research or leadership?
So, to answer that question briefly, I would restrict myself to the academic mentors who are in the academic institutions. So, there have been a lot many key mentors and role models related to this. And, to begin with, I would consider Professor Parthopratim Chakraborty. Uh, during my undergraduate days, he was a person we looked up to because he was a PGDM of his batch, and then he went on to pursue his PhD from IIT Kharagpur, a Bhatnagar awardee, and later, during my PhD, he also became the director of the institute. So he has been one of the primary influences who pursued me to stay back in India for my post graduation. Then Professor Shuman Chakraborty, who is my PhD supervisor, uh, in this forum and limited time, it is his testament of professional success. I shouldn't be trying to summarize, but as a PhD student, I got to see him personally up close, and as an excellent human being. So that is a quality that I try to emulate. Now, then again, as a part of being a part of this IIT Kharagpur fraternity, I got to experience many great teachers and mentors. And fortunately and very intimidatingly, now many of them are my colleagues. So I would like to name some great teachers, like, for example, Professor Ram Gopal in mechanical engineering, Professor Ghoshal in mathematics, Professor P.K. Das in mechanical engineering again. So, their teachings, in fact, their notes do help me a lot in, providing the teaching. And, obviously, in the professional world, I would like to mention Professor Sarit Kumar Das, who was the director of IIT Ropar. So I started my professional career at IIT Ropar. So I still remember one teaching that he imparted me the very first day I joined IIT Ropar. He called me to his office that evening and said that, try to learn something new every few years. That way, you won't get bored with whatever you are doing, and at the same time, you get to apply the new knowledge to a new field, and there, you can find out something truly novel. So that way, learning becomes a lifelong process, and you gain from it, and it becomes a symbiotic relation. So till date, I take that as a professional and a career mantra, and keep on keep that as a something to remember by. And yeah, last but not the least, not a classical mentor, but I think the students, undergraduate, postgraduate, and research students, guiding them through the classwork, research work, that has been a quite a mentoring. That mentors one a lot. The questions, the problems that they come up with, the challenges. It's always open-ended thing. Every challenge is a new challenge, and that sort of keeps the interest alive. So,
Yeah, thank you, Chirodeep. Now we have all heard about graphene.
yeah.
But can you explain your research in a layman terms, and also maybe you can throw some light in which you can understand what is the potential long-term impacts for a research on the energy system, diagnostics, because oil is a commodity which gets huge transportation is there, and we do see oil spills for which a lot of aquatic life is threatened.
Yes.
So we'd like, please explain on a layman terms how do you look about how graphene helps it.
So it would help if we go for a visual representation,
Yes, yes.
and I am allowed to share the slide.
One minute.
Yeah.
I think you can share this slide now.
Thank you. Please let me know if you can see the full screen. Can you view the full screen of the
Yes, yes, it is visible. It is visible.
Okay, okay. Thank you so much. So, uh, just in order to describe it in a layman's term, this is a very short presentation. I've tried to keep it, uh, as general as possible. So, to give a background of this technology, although we are, aiming for the renewable sector, till date, fossil fuels are, the major, they supply the major chunk of energy. And, crude oil is the backbone of the fossil industry, and the petroleum and crude transportation has to happen either via pipelines or, pipelines which are mostly, they go either underwater or through water bodies or through ships, because that is, through ship transportation is one of the most low carbon emitting systems. So, and when such thing happen due to leakages and accidents, a oil spill is inevitable, and the outcome of an oil spill is very, very detrimental to the ecosystem. As you can see from the images, this is what a sea or the the fauna there looks like after oil spill. So as we have understand, so it would typically block all the oxygen and sunlight, creating in depletion of oxygen and uh, strongly detrimental for the flora and the fauna. It creates a problem for the aquatic birds and the fish. So now, what is the classical problem with oil and water? We know that oil and water do not mix, but what happens when an oil spill happens? And what is the problem with the traditional approach? So the traditional approach consists of mechanical, chemical, or in situ burning. Now, the mechanical approaches are not resilient to the wind, waves, and tides, because the oil would spill off after some time, and moreover, it is not recoverable. Chemical or burning approach is a lot is greenhouse producing, and at the same time, it creates chemical pollutants, and also the oil is rendered unusable. So so, in order to look into the chemistry, we have to understand what is the issue with a mixture of oil and water. Now, we all know that oil is less dense than water and hence would float on the water. But at the same time, oil is more viscous than water. So, if we try to use gravity-based technique, like for example, we see the beaker here, if we try to decant of this beaker, or have a gravitational settling of the beaker and tilt the beaker, what is going to happen is that the water would come first because of gravity, and the oil would mix with the water. Then again, if we try to push the water out from the oil, water being less viscous would create an unstable interface, and that would spread in the oil. So classically, oil and water do not mix, they are immiscible. But the moment we try to separate them, the interface gets diffused and the mixing starts. Now, one of the classical examples or experiments that were first performed in this was in the 18th century, somewhere around the mid 18th century, where Benjamin Franklin in London spilled a spoon of oil onto a pond and saw that it always used to wet or still waves across the same area. Now, the thing with oil was that, at that point of time, Benjamin Franklin was a part of the Royal Society, mm, uh, 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 Royal Society, and he posed this question to everyone, but he and the others in the Royal Society could not answer this question, only to be answered after a period of 100 years by Rod Rayleigh, who actually, took the volume of oil, divided it by the area over which the oil spreads, and found out that is actually the molecular thickness of the oil. Now, incidentally, the paper that we are talking about today has also been published in the Royal Society of. Obviously, today we have much modern techniques like X-ray crystallography to measure the thickness of an atom, But classically, we can perform this experiment even at home by taking a known volume of oil and spilling it over a surface of water. The thickness of a monoatomic layer can be calculated. Now, the question comes, if I have to separate oil from water, I have to go to this atomic level to ensure that layers of oil are uh, uh, ripped at a level of one atomic thickness. And, obviously, when we talk about atomic thickness, the wonder material, graphene, comes into our imagination. Now, graphene has a hexagonal structure, 2D structure. It has won the Nobel Prize. We know all this. It has excellent electrical properties. It has a single layer of graphene has the highest thermal conductivity among any material known to man. So, what is this magic about graphene? The thing with graphene is that it can be functionalized. It has a unique structure, and that structure can be functionalized by additives so as to create a structure versus wettability tuning so that the oil and water can be separated. So we use this technology. So starting from absorption at the molecular level to filtration, and then via surface modification, we devise a eco-friendly and reusable setup which can skim off oil from the layer of the water. Now, it basically is a complete passive device, just requiring some amount of temperature at certain point. Now, that temperature, just to actuate the system, can be obtained by the solar radiation that is available over the sea. So, a concentrator can be optionally used to concentrate solar thermal radiation onto a point, and this device would be acting to remove the oil, not only cleaning the sea, but also making the oil recoverable. Uh, so, the device is reusable, it is scalable. Graphene is bilayer, 2D layer, so it is scalable. It can be used for a different environmental conditions. It is in fact more suited to tropical conditions where you have ample sunlight and temperature gradients can be obtained easily. It is totally eco-friendly. It doesn't cause any greenhouse gas emission, and it is very cost. Now, the entire study has been done over various scales. We start from uh, molecular scale simulation, which would do a oil-water interface molecular investigation. Then we try to build a bridge so that a lab-to-field technology can be evolved by upscaling this through experimentation. So these are certain experimental slides, and uh, and obviously, all the research that we do, the credit goes to the students. So we received a lot of recognitions for this. It was published in RSC Nanoscale. Then it went on to be the cover article of the RSC Nanoscale, and then Times of India picked it up for the front page article. And obviously, the credit behind this goes to two of my PhD students, both Prime Minister's Research Fellow, Mr. Vinay Arya and Mr. Obhirup Chaudhary. So this is a part of their work. They do work on different areas, but we would come back to that at a later instance. So at this point, I would stop sharing. And
No, that's nice. We see some the parts of it, but has it been tested or applied anywhere in the oil spills? This.
So in one of the slides, we showed a setup. We did a lab testing, not an on-field testing. So that is in progress. Lab testing, it does work.
So another point which you told was that it takes the energy from the sun because it has some operating temperature. What I understand that for this technology to work.
Yes, yes.
So now the ships by which the oil get transferred, they get transferred in the different seas. Some of the seas. So which part of the world this technology will be more suitable? Because some of the seas, the temperature or the sunlight, or it is suitable all the places.
It is actually suitable for all the places. Temperature just acts as catalyzing the process. So higher temperature would make the process quicker. The graphene-based membrane filtration is suitable for all temperatures. Of course, obviously, if the water freezes, if it is no longer liquid, then it won't work. But unless you have liquid water, this technology would work effectively.
And I think this will work also in current of the existing oil spills, which has already happened. Maybe some.
Yes, exactly. So basically, especially in tropical regions, you can have a towed boat and install this device along with probably a PV panel, and that would be a completely carbon neutral solution to remove the oil spill.
Okay. And how much does this? What is the cost of this technology compared with the current technologies which are being used?
The cost is pretty much inexpensive.
Okay.
We come up with some mathematical numbers. However, scaling up an actual cost of field implementation, that is still underway. But lab scale experiments, the cost is negligible, almost 10% compared to all the other technologies. And more importantly, it doesn't have a chemical footprint.
Okay. 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 Uh, So yeah, now your research spans from the various application from the fuel cells to water harvesting. Uh, so there are some fundamental connections also in this different areas. What it looks like from the your presentation.
Right. Right.
Now now your area also has a lot of interdisciplinary research because so how do you see the challenges? Is the technology is already perfected, or you feel that there some more improvements or uh, technology innovations can still possible on this?
No, if we look into the interdisciplinary field of research, there is a lot of innovation that is underway and lot of ground that we are yet to cover. See, one of the problems with interdisciplinary research is that the terminologies are often colliding and people do not understand the terminologies. So that's why there is always a fear of going into interdisciplinary research because people do not always communicate properly. So however, the complementary expertise of all the people that helps, to bring in real novel and truly new ideas. So, that way interdisciplinary research has a lot to do, and that is what we try to do in our lab. So,
Okay. Now, Dr. Chirodeep, uh, you have been there are a lot of awards and recognitions you have received. Also, you have extensive publication records. So, which are the awards or recognition you feel have motivated you, or you feel uh, you prize them the most?
see, you always like a award or a recognition, so keep them coming. So you cannot actually discriminate between the awards. You get an award, it feels good always. So, but rather, what is I think what is very important is the emotion that is attached to an award. So, and so that way, when I got the Faculty Excellence Award in 2023, it was a very unique experience because one of my batchmate, Vidya Bhushan, was getting the Young Alumni Achievers Award sitting across the aisle. So, it's in Netaji Auditorium. We are not allowed to move or, there's a seat H mark for us. We need to sit there. So we found a, small gap somewhere in between and we managed to click some awkward selfies in the darkness. So the emotions that are important. So again, this beginning of this year, I was elected as an associate in the West Bengal Academy of Science and Technology. So, and along with me, Professor Shuman Chakraborty, Professor Shunando Dasgupta, Professor Brajesh Dubey, whom I look up to as my role model, mentors, academic stalwarts of IIT Kharagpur, they were also inducted as fellows. Okay, the fellow is a higher than associate member. So, just to be standing with these giants, academic giants, it feels good. So, it's basically the emotion that is attached to it.
No, thank you. Uh, yeah, you see, now pollution is a very important part, whether it is air pollution, water pollution in today's environment, because we are every day dealing with part in and out.
Hmm.
So, What role a climate resilient infrastructure plays in your vision for a sustainable future? Because till the time we are using oil as one of our main transport mechanisms, this kind of
Hmm.
oil spills will continue to happen
Hmm.
because of some accidents and whatever. So, what
Yes.
kind of role you feel these technologies will come, and is any research on this graphene based is it going on in anywhere else?
Yes, not only see on graphene, graphene, as I said, it's a wonder material. Many people are researching on graphene because, it's a very good thermal conductor when it's a single layer. So, modern day microelectronics look into graphene heat sinks. Then a lot of other applications, circuit integrated applications, then material science, they are looking into graphene. Uh, not only graphene, several technologies to address the greater sustainable development goals. The threat that we have now currently, the pollution, greenhouse effect, rising sea levels. So all these things, so they need to be addressed in a holistic manner. And so we are sort of a blind man trying to understand the concept of an elephant. So we are trying to handle it with different parts. And if you allow me 5 minutes, we would try to I would try to focus on different technologies which our lab is currently undertaking. So
Please go ahead.
yeah. So I would share, as I mentioned, student are the key drivers. They are the actual, fuel to the machine. So they lead the work. So I would briefly go through the different areas of sustainability that we are addressing. So Vinay Arya, as I said, he works on molecular physics and how do we upscale this molecular physics to different purposes. For example, pumpless water transport, waste heat recovery. Along with this Abhirup, who works with interfaces. Now, as you can see here, the video playing shows a small paper, which is very similar to graphene. It's not graphene, but it's very similar to graphene, much cheaper than graphene. You can see, just dropping some water, plain and simple water that we drink, can cause in the LED bulb to glow. So it is basically energy harvesting from nothing. Obviously, interface and other things play a role. And then again, technologies like self-assembly. So we all know that when coffee spills, it makes a stain. Can we, you harvest this stain into molecular assembly to do something productive? And similarly, upscaling this to an extent where we would use this pattern in order to harvest water, because you know uh, just like energy, water crisis is also a real thing. So harvesting water also becomes important. And finally, it also works on self-powered diagnostics device. So I would come to this again later. So also, further upscaling from molecular level to, a micro scale and milliscale level, hydrogen is a very important energy storage medium today. And compressed or liquid hydrogen needs to be transported. And that transportation has to happen in a safe manner. So Anirban Roy works on sloshing and spilling of liquids under different conditions. So if, there's a toppling, what happens? And, you know, he uses this. So basically, it uses the inherent fluid mechanics or flow of droplets and jets on a surface, and that can be extrapolated to cleaning of solar panels. Now we know that solar photovoltaic is a major source of energy, and solar panels do get dusted and soiled, and that has to be cleaned in an energy efficient manner. And the same technology of how not to spill the hydrogen can be used to spill a droplet of water in order to ensure that limited amount of pumping, limited amount of water can clean the solar panel. That's a sustainable approach to solar panels. uh, then range, talking about harvesting the droplets, we see that whenever we have a interface which is thermally energetic, heated, that energy can be utilized to you see the droplet has an automatic motion as it is dropped onto the surface. There is no external energy to it. Now this can act as a micro scale heat pump, and the same energy can be utilized to harvest the power in an external circuit. So be it drops or be it a droplet falling on a characterized surface, this can be used to harvest energy. Chirodeep, who is also a Prime Minister's Research Fellow, works in this area. Then moving on, Deeptesh, also PMRF, he works on the, so earlier you asked, fluid flow and fuel cells, how are they related? So, fuel cell, the reaction is between hydrogen and oxygen, and it happens on a catalyst bed across a membrane. Now, the moment this reaction happens, there is formation of a water droplet, which is the byproduct of the reaction, and this water would sit on the membrane unless until it is removed off. So it is very pertinent to clean the droplets so as fresh hydrogen and oxygen can come in and reuse the catalyst for the next level of reaction. So here we work on those PM fuel cell. Diptesh works on that, and also anti-icing, anti-frost surfaces, pesticide deposition, how to effectively spray a plant with pesticides and all those. So wherever a droplet needs a directional transport, Diptesh is the person to go to. Then obviously going to a larger scale, we need thermal management of battery systems. We need management of heat sinks, photovoltaics. So there, designing air-cooled systems, liquid-cooled system is of key importance. And Shashi Rastogi, who is a research scholar, works on tuning these surfaces so as latent or sensible heat transfer can occur from this surface. So as you can see, using bubbles and droplet formation, he manages to remove heat from interfaces effectively. Then, moving on to higher scale, mesoscale, process intensification is a very important thing. Pallavi here works on use of nanofluids, the nanoscale and molecular technology to upscale it for process intensification in liquid flow systems. Now, earlier we have already established the fact that crude oil and internal combustion engines are here to stay for some more time, and that would require transportation of heavy crude. And now Ekta has come up with a very interesting idea to transport this heavy crude in a very energy efficient manner, where she uses water in combination of heavy crude oil to drastically reduce the cost of energy that is required in cross-country pipelines. Then moving on to an even greater scale. Now from device scale, we move on to system scale, because that's where we live. Our habitat, we are living in an artificially conditioned place, which needs air conditioning, artificial lighting. Even in broad daylight, we need artificial lighting. So there are several things which would require optimization so that we switch to a more sustainable thing. Shoparna Chakraborty, another research scholar, works on district level modeling, where he employs various fluid flow and thermal management techniques to promote passive cooling and passive energy conservation strategies. Vikas Chandra also works on modeling of energy efficiency and thermal comfort in buildings. Now, we classically have adopted the international thermal comfort understanding and use, our understanding of AC is, if you have to conserve energy, switch the AC to 24. But there are other interesting ways. So Vikas here explores those ways and tries to integrate renewable energy to building modeling.
Can I quickly ask a question?
Yes, please.
Sir, you talked about a little bit about the water, and we were talking about the pollution. I was just wondering if with existing cars, has anyone ever thought of actually passing the exhaust through water, simply through water? Because I know it might require a lot of maintenance, but just from a perspective of the amount of pollution that comes out of the current cars, just simply passing it through water, there is that little bit of a catalytic converter there, but that is not much of a thing. But if the car exhaust is passed through the water, is there any research or do you have an opinion of whether it might actually, from my estimate, it should reduce particulate matter by 99% at least?
That's a very good, very interesting question. See, water, in fact, the particulate matter suggestion is very nice, but there are certain inherent problems with water. First of all, is that, the amount of exhaust, the water has to be proportionate to the exhaust. And if we are, trying to put a bulk of water along with a moving vehicle, that is going to increase the, payload of the vehicle, and that would cause in more fuel expenditure. Secondly, we are here talking about two sorts of pollutant. One, the gaseous pollutant, like SOx, NOx, carbon monoxide, things like that. So these usually would require a catalytic converter, because I need a catalyst to, catalyze the reaction and to give the exhaust out in the least harmless, the most harmless thing possible. But water is, in water, all these gases are sparingly soluble. So after a point, that would saturate. And, if I'm trying to bubble the entire thing through the water, it would take a whole lot of time for this exhaust to pass through. So the idea is extremely interesting, but, it would take some sort of iterations and yeah.
Yes, sir. It's just a thought. I just thought that because there'll be a lot of maintenance required. You would have to put the water every day because it'll boil out, etc. So you might need to put a coolant, etc. So at least, but it's just a thought, because what happens is the gases are okay. But anyway, do have a thought about it. Thank you.
Yeah. Thanks for the question. Maybe we can discuss it sometimes.
Yeah, thank you, Anit, for the nice question. And I thank you, Dr. Bakli, that you have also introduced your team, like Shubhradeep, Anirban, Diptesh, Shashi,
Yeah.
Pallavi, Ekta, Shuporno, and Vikas. You see, it's very great that you and your team are doing a very great job, and even the technologies which you have been telling, like the cleaning of the solar panels. Solar panels are very widely used, or the hydrogen-based technology, because hydrogen, I think, is going to be a fuel of the future. Not only in a very big way for the Indian Railways, but also for many of the heavy motor vehicles. So I think most of these technologies will be very useful in times to come as they get developed. I wish you and your team a very bright future. We have with us here our president, Shri Raja Venkat. Raja sir, if you can kindly come and have a few words about our this current webinar. Raja sir?
Sir, you are muted.
Right. Yeah, now I think I'm audible, right?
Yes, Raja sir.
Thank you very much, Professor Bakli, and thank you very much. It was a very interesting communication that you've been making. And I also noted the question that had come from, Annette. And these are the kind of things that all goes in our minds when we see a lot of pollution happening. And our secretary also asked you a very interesting question on pollution. Now, I know you got an award also earlier, and such wonderful things you please keep doing, and then keep informing us. All the people should know about it. The students should know about it, then they can work in the right direction. Thank you, Siddharth, for doing a wonderful presentation. Okay, thank you very much.
Thank you.
Yeah, thank you, Raja sir. And Dr. Bakli, we will seriously like, once this technology are developed, that they also come forward and they speak, because many of our alumni are in very senior positions. I'm quite sure that the technologies can be put to right use. You see, all the time, we don't get a front paper newspaper display of the technologies. But many technologies are being developed at the IITs. We do look forward for these technologies because we don't know what are the things being done. And from our end, from the foundation, whatever is possible for us, we would like to encourage research, and so that we can use it at the end of the day.
Can I make one suggestion?
Yeah, please, sir.
I'm a 65 graduate. So I have not understood everything, but I wanted to ask you whether you have a mechanism of finding industrial partners. Mechanism, otherwise you keep waiting for somebody to approach. But instead of that, some mechanism that at some stage of research and the results which you have received in the lab, you should be thinking of who are the candidates who can use it in the industry. That is one. Second, whether you are simultaneously looking at the possibility of patenting some of your areas.
Thank you for the question, sir. So I would answer it in the reverse order. Yeah, we have in fact patented a lot of these technologies, and some are underway. And regarding SOP for industry approach, we do not have something very strict as of now. Like we try to, typically DRDO, ISRO, they come up with this problem compendiums, and we try to, approach them. From time to time, there is a call from various government bodies which look into industry collaborators, and probably, we approach our industry then and there through, social media, LinkedIn, trying to collaborate with them. It would be wonderful if, the Alumni Foundation tries to, come up with because, we have an alumni base which is broad and vast, probably, one of the largest in India, obviously, and one of the largest in the world. So, if we can come up with such a compendium which is available with the institute, and whenever we come up with this technology, we can, find the complementary taker and collaborate. So that would be something wonderful.
Anyway, one should think proactively, because DRDO, etc., all the government institutions, they'll approach you anyway because they look at IIT Kharagpur with that kind of image. But the industry, first thing is to identify within the country or outside the country, which are the industry which will be requiring what you are trying to achieve.
Right.
So once you have that knowledge, then approaching them is not so difficult, because these days people have their social media, or you can write to them on the email, and somebody will react to that. So knowledge of which place in anywhere in the world would be interested in that particular research which you have done. Once you have that knowledge, then proactively approach them and see whether you can get some reaction. If you approach 4 people, maybe one of them will react to it.
Yeah, Dr. Chirodeep, we have a question from one of your senior. He is from the 1996 batch, Debraj Dhar. So there were 2 questions. The first question, what was the cost of these technologies compared to the current technologies? This I had already asked. But the second question is, can the pollution get recycled using any mechanism? This is for improved sustainability. The pollutants in many cases have rare metals, carbon compounds. Would it be great to have them recycled?
Yes. In fact, that's a very interesting question. So, the traditional ways usually deal with, pollution management in a macroscopic way. So at that scale, recovery is not always possible. But if we try to look at from a microscopic point of view, okay, maybe, smartly designed droplets, smart interfaces, we can recover certain materials from certain components from this pollution and recycle them. So that is in fact a very interesting approach, and waste valorization, or it is called typically termed as waste valorization. So that is a very common approach.
So, all of you who are who have joined the webinar, we have briefly asked about the research from Dr. Chirodeep. So the session is open. If any of you have some questions, you can just put those questions to Dr. Chirodeep.
I see a raised hand.
Hello, Dr. Chirodeep. Thank you for the session. I was really impressed with your work, and
Thank you.
I'm a PhD student in nanoengineering from USA. I did my master's in chemical engineering from IIT Kharagpur. So we are going towards a startup which is funded by US government, and I would like to collaborate with you on the specific work, because that could be a really interesting work, because we are also working on the complementary technologies. We are basically interested in capturing this carbon dioxide and converting it into valuable chemicals. So actually, I was going through my mail, and I looked at this, and this is a very important webinar. Then I found this technology is really very crucial for some of our technologies. And how can we talk about after this webinar about stuff?
Yeah, sure. You do have my email ID, I believe. You type in my name. My name is very uncommon. So
Yeah.
the first thing that you would hit is my yeah. You can contact me over there. Then nowadays we have WhatsApp and other things. We can contact very easily. Thank you for joining the webinar. We would surely follow up on this.
Yes, sir. This is really interesting, because I never thought this kind of research is going back in IIT Kharagpur. I was really impressed with this kind of work. I'm happy to collaborate and take your technology to commercial.
Thank you.
Yeah,
Looking forward.
thank you, Vamsi. That's what we are looking for as a foundation, to connect from the technology, what is being uh, innovated, how they can be commercialized. So
Yeah.
we can build up more technologies from the technical institutes. Thank you.
Thank you.
So, Dr. Chirodeep, what are your future research plans and aspirations?
As my plan goes, I do have a slide for that as well. So let me just go ahead and again reshare. So before we move on to future plan, so these are some of the PhD students who have graduated from my lab: Dr. Nilanjan Mondal, Dr. Avinash Kumar, who is in IIT Madras now. So they have worked on varied technologies like heat sink cooling, DNA translocation, and energy generation. Now the future technologies lies with them. So these are the first year PhD students. So they are the future. So in future we would plan to look into 4 aspects. One, starting at the very physics level, where we try to find how does small scale and large scale, what is the interconnecting physics in it. Chirodeep looks into that. Rahul upscales it a bit, so where we actually go into systems and we try to design self-propelled systems. Devmallo looks into energy systems, so large scale energy systems, multi-phase, multi-system energy systems, and how do we work on that. And Protein looks on to something very different. How do machines and human interact? So what is the impact of various energy systems, including energy poverty and the access to various resources, thermal comfort onto human so so I do plan a future which is sort of varied and interdisciplinary, just like what I am doing now. And so I have a decently large team. So this is about 50% of the team, UG, PG, and RS. So so that's the key, to look into interdisciplinary research so as to provide sustainable solution to various problems.
Yeah, thank you, Dr. Chirodeep. That's very nice. What advice you have for the current students or the early stage researchers who are interested in pursuing a similar field?
Some very simple advice is to remain open to interdisciplinarity. People usually fear multidisciplinary, interdisciplinary. Be open to them. Stay curious. Before you venture into research, have a strong fundamental base, because your fundamentals would help you to imbibe any new idea. Find a good mentor. That is the most important step. Prioritize communication and networking. That is a very efficient, very important skill. I have done something very interesting, but unless until I say it out loud, no one is going to appreciate it. So communication and networking is the key to disseminate research. Then obviously learn to handle failures. Failures are the pillars of success. Sounds cliche, but that's true. And irrespective of failure, stay consistent. Success would come your way. Most importantly, take care of yourself. Your physical and mental health comes at the very beginning. Prioritize it and remember why you wanted to do the research at the first place.
Yeah, thank you. We can have few more questions from the audience. You have almost 1 hour. This presentation is going on from Dr. Chirodeep. Any more questions from the audience? Yeah, Dr. Chirodeep, now as I told earlier, like we would like to encourage this kind of research activities, and we'd like to disseminate this knowledge among the alumni so that this gets commercialized, and the research which is being done, we get the benefit out of that. So we will also request your help. You are a 2000 batch alumni. Please help us in knowing one of the research which is being done at IIT. We would like to call them, provide them this platform so that they get connected and we also get benefited. We do look forward for that, because every month we are having this session. We call one of our alumni either on the 4th or the 2nd Saturday at 5 p.m. And we, in whatever leaderships formats he's having, it is in research or business, and this we have started since last year, and we do look forward in continuing it every month. I sincerely thank you for sharing with us the groundbreaking research, and I also thank your team who are working on very important research, which are like the hydrogen-based or the cleaning of the solar cells, which will have quite a big impact in times to come. I also thank all the audiences who have joined for making this leadership series lecture a very successful one. Thank you, Dr. Chirodeep.
Thank you.
Thank you. Thank you very much.
Thank you.
Thank you, sir. I'll mail you. Thank you very much.